See, good morning, students. In the last class, we have discussed about the Fourier transform. In this class, we are going to discuss about the Laplace transform. Write the definition and notation of Laplace transform. Let a function f of t be continuous and defined for positive values defined for positive values of t. The Laplace transform of f of t associates a function of s associates a function of s defined by the equation defined by the equation f of s equal to integral over 0 to infinity e power minus st f of t dt. This equation number 1. Here f of s is Laplace transform. F of s is Laplace transform and it is denoted by L of f of t. Functions of heading functions of exponential order. Functions of exponential order. Write the definition. A function f of t is said to be of exponential order exponential order s suffix 0 if there exists a number s0 if there exists a number s suffix 0 such that such that limit t tends to infinity e power minus s0 t f of t equal to a, that is finite quantity. Finite quantity. For example, for example, f of t equal to t square, f of t equal to t square is of exponential order is on exponential order 3. Since since limit t tends to 0, since limit t tends to infinity, e power, here f of t is t square na, f of t is t square, e power minus st you have to take, e power minus st, some value. Okay, I am taking 3t, e power minus 3t, s0 is some number. So if you are taking s0 is some 3, so s0 e power minus 3t t square. So what happened? Limit t tends to infinity, t square by e power 3t, that is equal to infinity by infinity, that is indeterminate form. It is form of infinity by infinity. So what is the next step? What is the next step? Am I audible?
Yes, sir.
Then if it is a form is infinity by infinity, then what is the next step? Using L'Hospital rule, using L'Hospital rule applying here, that is t tends to infinity, limit t tends to infinity 2t by 3 e power 3t. Once again infinity by infinity. Once again limit t tends to infinity 2 divided by 3, sorry, 9 e power 3t. So that is equal to e power 1 by infinity, that is equal to 0. It is a finite quantity. So it is a exponential order. F of t equal to t square is an exponential order of order 3. One more example is in case if you are taking e power t square. E power t square is not of exponential order. How can you say that e power t square is not an exponential order if you are taking any value of s naught? For example, so if you are calculating that e power t square is of exponential order, then what happened? Write down, since limit t tends to infinity, t tends to infinity, e power minus s0 t f of t. So what you get, that is equal to limit t tends to infinity, e power minus no minus s0 t e power t square. So limit t tends to infinity, e power t square minus s0 t, that is equal to infinity. Therefore, it is not an exponential order. Sufficient condition for the existence of Laplace transform. Sufficient condition for the existence of Laplace transform. If your function f of t is piecewise continuous, piecewise continuous. So what is called a piecewise continuous? Even if you are divide that interval into a finite or infinite number of subintervals, the function is not changing, then it is called a piecewise continuous or sectionally continuous. Sectionally continuous in a closed interval, in a closed interval alpha less than or equal to t less than or equal to beta and is exponential order and is exponential order and is exponential order, so then Laplace transform f of s exists. F of s exists. F of s exists for all s greater than s0. Where s0 is the number constant. sectional and piecewise continuous. Heading sectional and piecewise continuous. What is called sectional and piecewise continuous? A function f of t is said to be piecewise or sectionally continuous. Piecewise or sectionally continuous in a closed interval alpha to beta if it is defined on that it is defined on that is defined on that interval and is such that interval and is such that the interval can be divided into a finite number of subintervals a finite number of subintervals in each of which f of t is continuous. F of t is continuous and has finite limits and has finite limits as t approaches each endpoint of the division each endpoint of the division from the left as well as from right. This means that f of t can be it can be can have only ordinary finite discontinuities in that interval. Discontinuities in the interval. The interval. Here, take one interval alpha, closed interval, this value is beta. Okay. So here I divide that into subintervals, into subintervals. The subinterval values are T1, T2, T3. Okay. So here alpha to beta, any function, right? So these are the four different functions. The above is the key graph of, it is sectionally continuous. It is sectionally continuous. Piecewise continuous is different. Piecewise continuous mean if you are taking the single function from here to here. So if you are subdivided into any subintervals, you can get that the same function, that is T1 plus h or T1 minus h, will get the same function. But it is sectionally continuous. Sectionally continuous mean if you are taking any value in between that alpha to T1, okay, it is one function. Okay. Now here you can write that the above is the graph. The above is a graph of, is a graph of a sectionally continuous function. Sectionally continuous function. This function has discontinuities. This function has discontinuities at T1, at T1, T2, T3. Actually, at T1, T2, T3, it is discontinuous because it is a three different functions. At t equal to T1, the function has finite limits. T equal to T1, the function has finite limits. The function has finite limits. As t approaches T1, as t approaches T1, from either side, from either side. The two limiting values, the two limiting values are not the same. See, actually, if you are preparing some any gate examination like that, that is, you have to know a clear-cut idea about the limits and continuity. Limits and continuity. Actually, the limits and continuity, if you know that very well about that limits and continuity, I'm writing the rough work here. The topic is, and then one more thing, not only for that preparing that examination, any entrance examination like that, uh, for to get that better idea about the differentiation and the differential calculus and differential equations better you have to study that limits and continuity. Actually, the limits and continuity basic in available in tnbooks.com. You better you print out the sorry take the download that book plus one volume 2. It is downloadable only. All the books you can download. So in the tnbooks.com plus one volume 2 book, that limits and continuity is given that elaborate, very elaborate. Many examples are given, and then you will get that yeah clear cut idea about that limits and continuity. Okay, how it is that approaching to T1, why it is not that same from left side, from the right side. Anyway, at T1, it will be that two different position it will come. But from the left side, the function is different. From the right side, the function is different. But both of them, both the functions are approaching T1. Okay, these things have given, many theorems are given in the book. So their two limiting values are not the same. F of t is said to have f of t is said to have a finite or ordinary finite or so these are like MCQ questions. The two limiting values are not the same. F of t is said to have a finite or ordinary discontinuity. Finite or ordinary discontinuity. Ordinary and discontinuity at the point t1. At the point t1. A continuous function is also a continuous function is also continuous function continuous function is also piecewise continuous piecewise continuous but the converse is not true. The converse is not true. Function of class A. Function of class A. Function of class A. A function which is sectionally continuous. A function which is sectionally continuous sectionally continuous over any finite interval over any finite interval and is of exponential order and is of exponential order is known as a function of function of class A. If f of t, write the notes. If f of t is of class A, and L of f of t equal to f of s, see already I used that notation for f of s for Fourier transform. So here I can use that phi of s for the Laplace transform. In the beginning also I given that f of s, we change it that phi of s because already used that f of s for the Fourier transform. For the same subject, if I assign that same notation, you will get confused. So phi of s you can write phi of s. Then then limit at s tends to infinity. Limit s tends to infinity. Phi of s equal to 0. Second one, s into pi of s is bounded. S into pi of s is bounded as s tends to infinity. Next one, if the Laplace transform of f of t is L of f of t equal to phi of s, then f of t equal to L inverse of phi of s is known as inverse Laplace transform. Inverse Laplace transform. So here what is the condition for existing existence of inverse Laplace transform? Condition for the existence of the inverse Laplace transform. That condition is called a Lech apostrophe S theorem. Lech theorem. Statement: if f of t is piecewise continuous, f of t is piecewise continuous, piecewise continuous in every finite interval, in every finite interval, every finite interval, and is of exponential order. And is of exponential order. Then L inverse of phi of s, L inverse of phi of s equal to f of t is unique. Can I rub the board? Did you complete it?
Yes, sir.
Hmm?
Complete it.
Hmm. See, regularly I uploaded the previous class videos. Uh, if any previous class is missing, let me know because I need to upload. I maybe miss any class to upload them. Okay, fine. Next one is properties of Laplace transform. Properties of Laplace transform. Laplace transform of two function f1 plus f2 plus fn equal to Laplace transform of f1 plus Laplace transform of f2 plus etc. Laplace transform of fn. And then one more thing, Laplace transform of f1, f2, fn is not equal to Laplace transform of f1 into Laplace transform of f2, Laplace transform of fn. See, keep it in mind. Only for that addition and subtraction, you can write like this. If it is in multiplication, you are not able to write as a multiplication of Laplace transform. Similarly, Laplace inverse of f1 plus Laplace inverse of phi 1 of s plus phi 2 of s phi n of s equal to Laplace inverse of phi 1 plus Laplace inverse of phi 2 plus Laplace inverse of phi n. Laplace transform of simple functions. Laplace transform of simple functions. 1. Laplace inverse of 1. Laplace inverse of 1. Laplace inverse of 1 is, how to find that? Laplace transform of f of t equal to integral over 0 to infinity e power minus st f of t dt. Here f of t is 1 na. Is equal to 1 by s. So Laplace inverse of 1 is 1 by s. The Laplace inverse of constant entity f of t equal to constant L of f of t. Find the Laplace transform of e power a t. Find the Laplace transform of e power a t. So e power minus s minus a t dt. So e power minus of s minus a t by minus of s minus a from 0 to infinity. So that is equal to minus 1 by s minus a e power minus infinity minus e power 0. So 1 by s minus a. Similarly, our Laplace transform of e power minus a t is 1 by s plus a. So what is Laplace transform of cos hat? Cos hat. Cos hat is Laplace transform of e power a t plus e power minus a t by 2. So 1 by 2 Laplace of e power a t plus Laplace of e power minus a t. So 1 by 2 1 by s plus a plus 1 by s minus a s plus a 1 by 2 s square minus a square s plus a plus s minus a, that is equal to s by s square minus a square. Similarly, Laplace transform of sin hat equal to a by x square minus a square. Find the Laplace transform of, here a minute. Find Laplace transform of sin at, Laplace transform of cos at. So how to find the Laplace transform of sin at? Laplace transform of sin at equal to Laplace transform of e power iat minus e power minus iat by 2i, that is equal to 1 by 2i. E power iat is 1 by s minus ia minus 1 by s plus ia. So taking that s square plus a square LCM, s plus ia minus s plus ia. So s's get cancelled. Then we get that 2ia by 2i s square plus a square. So 2i get cancelled. A by s square plus a square. Similarly, we can get that the Laplace transform of cos at equal to s by s square plus a square. Find Laplace transform of t, Laplace transform of t. Find the Laplace transform of t, Laplace transform of t square. Laplace transform of t is integral over 0 to infinity e power minus sp f of t dt. So integral 0 to infinity e power minus st t d. Using Bernoulli's formula here, we'll get that e power minus, taking the t and e power minus st by minus s minus differentiation of t is 1 e power minus st by s square from 0 to infinity. For that 0 to infinity, this term is 0, so we will get that 1 by s square. So for that Laplace transform of t square, Laplace transform t square integral over 0 to infinity e power minus st t square dt. Here also you can use that the Bernoulli's formula t square e power minus st by s minus s minus 2t e power minus st by s square plus 2 e power minus st by minus s cube from 0 to infinity. So first two terms are 0 for 0 to infinity. Only last term will be there. So you will get that 2 by s cube. 2 by s cube. So this 2 can be written as 2 factorial by s cube. So continue like that. Continue like that. Continue like that. The Laplace transform of t cube is 3 factorial by s power 4 etc. Laplace transform of t power n equal to n factorial by s power n plus 1, where n is integer. Where n is integer. If n is not integer value, integer, then Laplace transform of t power n equal to gamma of n plus 1 by s power n plus 1. It's important MCQ. Find Laplace transform of 2 power t. Find that Laplace transform of 2 power t. Okay. That Laplace transform of 2 power t can be written as Laplace transform of e power log 2 power t. E power log 2 power t. So e power t log 2. E power t log 2. So it is log 2 is here, the log 2 is constant. Log 2 is constant, therefore it is in the format of Laplace transform of e power log 2 log not log 2t, log 2 into t. It is in the format of e power at format. E power at is 1 by s minus a. So that is equal to 1 by s minus log 2. Find the Laplace transform of t power minus of. So when n is not integer, when n is not integer, then Laplace transform of t power n equal to gamma of n plus 1 s power n plus 1. When n equal to minus of n plus 1 equal to half. Therefore, Laplace transform of t power minus half equal to gamma of n plus minus half divided by s power half. So gamma of half is root by root s. That means root of pi by s is the answer. Similarly, find that Laplace transform of t power of. Tell me the answer. These are all the MCQs. T power of.
So root pi by s power 3 by 2.
Hmm. The T power of is gamma of n plus 1 by s power n plus 1. When n equal to of n plus 1 equal to 3 by 2. So gamma of 3 by 2 by s power 3 by 2. But gamma of n plus 1 equal to n into gamma of n. N into gamma of n. Where n is 1 by 2, therefore gamma of 1 by 2 plus 1 can be written as 1 by 2 gamma of 1 by 2. So this can be written as 1 by 2 gamma of 1 by 2 by s power 3 by 2. So root pi by 2s whole power 3 by 2 is the answer. Find the Laplace transform of find the Laplace transform of 3t power 4. Find the Laplace transform of 3t power 4 minus 2t cube plus 4 e power minus 3t minus 2 sin 5t plus 3 cos 2t plus 3 cos 2t. So this can be written as Laplace transform of 3t power 4 minus Laplace transform of 2t cube by linearity property. We can separate that plus Laplace transform of 4 e power minus 3t minus Laplace transform of 2 sin 5t plus 3 Laplace transform of 3 cos 2t, that is equal to 3 4 by s power 5 minus 2 4 factorial na 3 factorial by s power 4 plus 4 by s plus 3 minus 2 by 2 into 5 by s square plus 25, sorry, sin na plus 25. Last one is 3 plus 3 into s by s square plus 4. Find the Laplace transform of cos at plus b. Cos at plus b. So how can we do that? Cos at is cos at cos b minus sin at sin b. That is equal to cos b into s by s square plus a square minus sin b into a by s square plus a square. That is s cos b minus a sin b by s square plus a square. Find the Laplace transform of sin t minus cos t whole square. Find the Laplace transform of sin t minus cos t whole square. Laplace transform of sin square t plus cos square t minus 2 sin t into cos t. So Laplace transform of this value is 1, this value is sin 2t. So 1 minus sin 2t, 1 minus 2 by s square plus a square is 4 here. Laplace transform of Laplace transform of sin 4t cos 3t. Sin 4t cos 3t. So how can you do that? Many of them were done the mistake in this problem is just they are finding that they can write this like Laplace transform of sin 4t into Laplace transform of cos 3t like that. Okay, it is wrong. You have to change it into that addition format. Therefore, what is sin a cos b? What is sin a cos b formula? What is sin a cos b formula?
1 by 2
1 by 2.
sin a plus b
Hmm.
plus sin A minus B.
Hmm. That is Laplace transform of 1 by 2 sine 70 plus sine t. So 1 by 2 into 7 by s square plus 49 plus 1 by s square plus 1. Problem for practice 1. Laplace transform of sin 3t sin 2t. 2. Laplace transform of sin square 3t sin square 3t. Find the Laplace transform of cos square 2t. Laplace transform of sin cube 2t. Find the Laplace transform of f of t equal to e power t when 0 less than t less than 1. 0 when t greater than 1. Okay. Do the problem. Any doubt is there? You can ask. Did you copy the problems?
Yes, sir.
Okay, fine. So stop the recording.